Plumber Exam the Warriors, video 7. Okay, let's see. Tub with shower, waterproof wall height. In other words, a tile or fiberglass enclosure, etc. It's got to stand at least 6 feet above floor or 70 inches above the drain. What's an easier way to picture this so we remember it? Here we go. We got our shower pan, our little shower whatever. And this is the finished floor. So, the shower, the waterproof, any kind of waterproofing we had for the shower, it's got to be at least 6 feet. It's got to be at least 6 feet from the floor. 6 feet from floor. Now, or 70 inches from the drain. How does that work out? Well, 6 feet is what in inches? 72 inches. Which means if we're measuring from the drain, they're considering it to be at most 2 inches above finished floor. If we look in here, it's 2 inches above finished floor. So 70 from the drain, 72 from finished floor, or 6 feet from finished floor. And make sure to subtract your 2 inches if we're talking about from the drain itself. Let's see. Potable water solder. Potable water solder is considered lead-free if it has 0.2% or less lead in it. Where do we get that from? We get that from the definitions chapter, where it says lead-free solder and flux is 0.2%. In the water chapter, we have what their definition of, or what they consider lead-free pipe and fittings for potable water distribution piping, and that's 0.25%. Not a huge difference, okay? One number is from definitions, one number is from water supply. They don't conflict. One is for the solder and the flux. Sometimes flux has solder in it. It's already, if you want a tin with it. And the other one is for pipe and fittings. Faucets, piping itself, fittings, either copper or brass, etc. This is a change from the 2014 code because we had a third mention in definitions that conflicted with the mention in the water chapter. They realized that, took it out. So we just have to know 0.2 solder and flux, 0.25 pipe and fittings. Faucet. Faucet is merely an end valve to draw or hold water. That's it. That's where water stops being potable because you're going to use it and then it's going to drain and now it becomes waste water, correct? So the faucet is that point. Faucet. The only thing that comes after the faucet is going to be the drain, correct? Vent stack or stack vent terminates outdoors above the roof. It will always terminate outdoors. Certain codes in the United States, as long as it's outdoors, a certain height above ground, you're fine. New York City, it terminates outdoors, but only through the roof. Cannot go through the wall, go through the roof. Ready access, as opposed to just plain access. Plain access is, maybe I'll need a ladder. Maybe I'll need a screwdriver to open up an access panel. Ready access means I can walk right up to it, see it, work with it, do whatever I got to do with it. Access is not, I got to take a hammer and open up a hole in the sheetrock to see where I got to go and what I work on. That's not access. Potable H2O, water. New York State. You see the NYS? That's not NYC, that's NYS. New York State Sanitary Code supersedes New York City Sanitary Code. New York State Sanitary Code says it can't hurt us. Water heater. Well, it's an appliance. or equipment that heats potable water for domestic hot water, as opposed to a boiler. A boiler heats water for heat, for space heating. That's a boiler. A water heater is strictly for potable hot water that we can drink, bathe, cook with. And notice a water heater, not a hot water heater. I mentioned before, a hot water heater is a redundant term. It is grammatically incorrect in code lingo. Combination waste and vent max vertical. All right, combination waste and vent system is a venting system that we're going to go over. It used to be strictly for exotic applications, no longer. Another change in the code. Combination waste and vent system now is strictly for floor drains, drinking fountains, lavatories, in a very specific kind of a location application, but only those three fixtures can empty into it because they are clear water waste fixtures, and there is no vertical piping. Usually, if you can imagine, like, let's say a school chem lab or whatever, and you have a million sinks where they're washing down stuff. Maybe there's a drinking fountain in the room. Maybe there's a lavatory there to wash your hands. There's a floor drain, right, to pick up spills. To run the vents for all of that, when all of these lab islands are in the room, is impractical. You know, if you've ever looked in it, maybe you work for the schools or maybe you work for hospitals, you'll see them. You'll see certain rooms where they actually have these islands, these lab islands. Take a look at them again and you see, oh yeah, no vents are running up there, and yet these fixtures require vents. You get one vent, and that one single vent, it'll be run in the wall somewhere. All the fixtures operate off of that one vent. Now, the 8 foot that they're talking about is, remember when we established that the longest, the greatest vertical distance we could have, which was also a change from 2014, is 4 feet from outlet of fixture to weir of the trap. We're allowed up to 4 feet. That's very generous compared to what we used to be allowed. For the combination waste vent system, you can extend that to 8 feet now. You can run from the outlet of all the fixtures you're working with, you can run 8 feet down before you eventually have to connect to the wet vented, the horizontal wet vented drain that's picking all that up. We'll go into detail with that, but the main thing is 8 feet, combination waste and vent system, longest vertical distance from outlet from fixture to connection with the horizontal, 8 feet. Okay, let's see. Where were we? Okay. Trap seal loss by evaporation. This is usually the emergency floor drain in the bathroom. Doesn't see a lot of water, right? And floor drains in general. These are the fixtures or receptacles you're going to be using. A trap seal primer. You must have a trap seal primer. Horizontal drain max cleanout spread. Horizontal drains must have cleanouts. How many cleanouts? Well, at least enough so that there is never more than 100 feet between each cleanout. And also at changes in directions greater than 45 degrees. Horizontal wet vent permitted for 1 bathroom group in the same room. This is why we stressed, what is a bathroom group? We established that it was a water closet, lavatory, tub with shower or shower. And then you can add a bidet if you want, and you can add a floor drain, because a floor drain in a bathroom is an emergency floor drain, so it's 0 fixture units, and they must be in the same room. If you can accomplish that, you only got to pick one of those fixtures to have the vent, run that vent, and all the other fixtures use that vent. Saved yourself a lot of work and piping. Vent stack is a vertical pipe primarily for circulation of air to and from the drainage system. That is correct. Why would we need that circulation of air? To equalize the pressure on either side of a fixture trap, because fixture trap seals are very delicate, so that we don't lose the trap seal. Why? Because the only function of the trap is to prevent the passage of sewer gases through the fixture. Okay, traps are strictly there to prevent the passage of sewer gas. Vents are strictly there to protect the seal of the trap. Where you don't have a trap, you don't need vents. Where you're not dealing with sewer gas, you don't need when you don't have to worry about sewer gas, you don't need traps. If you don't have traps, you don't need vents. If you notice, the only time, let's say we're dealing with the storm system, the only time you'll ever see a trap, roof drains aren't trapped. Have you ever noticed that? Roof drains are never trapped. Why? Well, because they're not connected to the sanitary. When they are connected to the sanitary, when you have a combination system and now you're connecting, you're going to run the risk that now, if you don't put a trap at the bottom of that leader or conductor, the sewer gas is going to work its way up through the roof drains. Now we can't have that. But when it's all by itself, you never have to worry about trapping a roof drain, even though a roof drain is technically a plumbing fixture. Let's see, what do we got here? Compound tape. Male threads only. That's always been the case, but something new in the fuel gas code, we are allowed, it says so, we are allowed Teflon tape on gas, except when we're connecting to regulators. You can't put it on the threads going into a regulator because they're worried that it frays off and the little bits get stuck in the delicate controls or whatever. Otherwise, you're running a riser, running branches, you got that roll of yellow Teflon tape in your pocket, feel free to use it. You are allowed to use Teflon tape on gas now. It's in the fuel gas code. You're good to go. Can't use lamp wick. Never have been able to use lamp wick, still can't do it. Teflon tape, you can do it. You have their blessing. Horizontal piping is considered anything less than 45 degrees. How does that work? We're always going to be dealing with horizontal, vertical piping. They're going to say when a piping is running vertical, blah, 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 or if a pipe is horizontal, or you don't have to worry about this if the pipe is horizontal, you don't have to worry about this if the pipe is vertical. So what does horizontal and vertical mean? And we established that by using the 45-degree angle as our line of demarcation. So, let's say we have what we call a horizontal line. Why is it a horizontal line? Because it is not breaking the 45-degree angle. Okay? So, technically, if we had a line running at 44 degrees, guess what? That's still considered a horizontal line. But the minute it is 45 degrees exactly or more, that is now vertical. Period. Okay? Strange. Weird as it may seem, but horizontal is anything that's less than 45 degrees. Vertical is everything that's 45 degrees or more. Okay? All right, let's see. Rough-in inspection is conducted prior to the installation of wall and ceiling membranes, the sheetrock and the roof and all that stuff, because, well, you can't cover it up until the inspector sees it, correct? So, rough-in inspection, you got to make sure the inspector sees it before they cover the walls, or else guess who foots the bill for having all that stuff taken down and put back up again? You do. It's your fault. You pay for it. You pay the bill. Minimum vent. This is a change from the 2014 code. In the 2022 code, the minimum vent is 1.25 inches. You can go as small as 1.25 inches to vent a fixture. If the fixture unit's value allows you, etc., you can go as low as 1.25 inches. Save yourself some money. Don't always have to run 1.5 every single time, or 2 inch every time. 1.25 inch, a lot cheaper. Island fixture venting is for sinks and lavatories only. You have a fancy kitchen, you got that beautiful island, you're not running the vent for the little bar sink or whatever kind of sink you put in there. I believe you're even allowed a dishwasher. Well, no, you're not, unfortunately. Just a sink and lavatory. But for that sink and lavatory, you're not going to run the vent through your marble or granite countertop or whatever, right through the middle of the kitchen, past your beautiful copper pot, hanging thing, whatever. You know, it's like, no. So how do you vent that? Real uglily, but it's underneath the counter. It's a whole mess of fucking pipes. It's disgusting. We'll deal with it. Pro-vents are such a better solution, but we're not allowed them. Regardless, island fixture venting, another form of venting, but you can only use it for a sink or a lavatory. Minimum condensate line up to 20 tons of refrigeration, 3/4 inch. This table is in general regulations. The smallest condensate line you're going to be running is 3/4 inch inside diameter. They kind of make a point of that one. So make sure it's 3/4 inch, not just nominal, but you got a full 3/4 within the piping material. So like extra heavy stuff probably is not, you're not going to be able to use it because, you know, whenever you go extra heavy on IPS, you're shrinking the inside diameter. So you're probably going to lose your full 3/4. Regardless, why do I give this to you? Because we're not going to bother to remember the entire table of condensate lines as far as the tonnage for appliances occur. We memorize this one easy line. 20 tons of refrigeration, up to that requires at least a 3/4 inch condensate line. If you get a question, at least you have somewhere to start with. Should be enough to figure out which is the right answer. But since we're on the topic, it wouldn't hurt to know exactly what we're talking about when we say a refrigeration ton. We're used to boilers. And how do we rate boilers? By BTUs. If I tell you that we are dealing with a 350,000 BTU boiler, you're going to know, or if you don't know, now you do, you're going to automatically think like, oh, that's a boiler in a house. That's a little tiny guy. I mean, I can pick that up and throw it in the back of my van or my truck and install it and, you know, make myself an easy, what, 800,000, right? Just for swapping that out. I mean, you could almost pick those up by yourself. That's a 350,000 BTU boiler. So we kind of generally have the idea of the kind of heat that thing is pushing out. It's pushing out enough heat for one family home, right? But what about an HVAC unit that does cooling, air conditioning? How do we rate those? We rate those by a refrigeration ton. Now, a refrigeration ton is well, it's easier to say what it's supposed to be able to do or what we imagine it can do. A unit that's rated at 1 refrigeration ton is able to create for you an ice cube 1 cubic yard big in 24 hours. That's a 1-ton unit. So an ice cube that's 3 feet across, down, deep, you know, it's 1 cubic yard big, approximately. If you do the math, you figure it out, because we figure 1 gallon of water weighs 8.33 pounds, and then we figure how many gallons of water there would be in a cubic yard, and multiply that by 8.33. You're going to see, yeah, we get pretty close in the area of 2,000 pounds, which is a ton. And it's about a cubic yard big. It weighs about 2,000 pounds. Well, that unit created that ice cube in 24 hours. Now, if you got a unit that can create 20 of those ice cubes in 24 hours, guess what? Yes, that unit is a 20-ton unit. And that's kind of a small unit. That's a standard unit is a 20-ton unit. If you look at the table, you're going to see the units can get pretty big. So you're making a lot of ice cubes. Those are some like really giant whiskey sours. I don't know what kind of glass you got to find to fit that ice cube in there, and then still have room for all the scotch you can pour over it. But that's what it can do. In the table, I'm looking in General Regulations, page 27, but you're going to see 20 tons of refrigeration, 3/4 inch line. What's the biggest one they got in the table? Over 125 tons to 250 tons of refrigeration, you would need a 2-inch condensate line at least. So that unit could produce 250 of the biggest whiskey sours you've ever seen in your life. That's a big glass, one ice cube in there. You really only need a 1-ton ice cube to keep it cold, and a hell of a lot of scotch to make it decent, right? But that's just a little tiny trip into refrigeration, HVAC stuff. Measurement along center line is developed length. We say developed length, it means we're measuring along the center line of piping. Very common question. Urinal waterproof wall. Okay, so we had to have at least, do we still have it there? No. We had to have at least 7 feet of waterproof surface for the shower. 70 inches if we're measuring from the drain. Well, the urinal needs 4 feet high and 2 feet on either side to be good. Now, I'm thinking, because now I'm starting to get into anal mode, okay, 2 feet. Are we measuring 2 feet from the sides of the urinal, or are we measuring 2 feet from the center of the urinal? And you're going to start getting that way too. You're going to say, wait a minute, Victor, but this measurement we're talking about, where are we making this measurement from? Because it makes a difference. So let me double check. Okay. Page 38 in the code, surrounding material for urinals. Wall and floor space to a point 2 feet in front of a urinal lip. Did I put 2 feet in front of here? Okay, I only gave you 2 of the items, right? So now's a good chance to say, well, 2 feet in front of the urinal lip. So if you got one of those long ones that stick out a lot, it's still 2 feet from the lip out. If you got one of those ones that are flatter against the wall, it's still 2 feet. It's going to be a different measure. It's going to be a different point on the floor for each of those models, but wherever the lip is, 2 feet in front. 4 feet above the floor, that we knew, and at least 2 feet to each side of the urinal. 2 feet to each side, not 2 feet from center. 2 feet from each side of the urinal. So the model of the urinal determines exactly where you're going to start measuring. If you got a skinny urinal, you start from the sides of the skinny urinal. You got a fat urinal, you start from the sides of the fat urinal. Regardless, it's 2 feet measured from each side, from the china, not from the center. Okay. Minimum slope for 2.5 or less drainage, 1/4 inch. I believe I have it here. Okay, remember we had our cadence, because this is going to start getting filled up with like our little abbreviated notation, and we're going to start learning cadences. We're going to start treating this as pictures of numbers to remember. So this was for our gas piping hangers. We knew that steel and copper pipe was every 12 feet. Steel for gas is still every 12 feet. Except though, you got to realize it's every 12 feet for 1.25 inches or bigger gas. For the smaller sizes, it changes just a little bit. The smallest gas we're running is 1/2 inch. It's going to be every 6 feet. And then, well, what's left? Well, in between are only 2 sizes left. So if you forgot, don't worry. You know your pipe sizes like the back of your hand. So there's only 2 sizes left, 3/4, 1 inch. There's only 3 numbers we're remembering. We already have the 6 and 12, so 8. But now, pitch. Pitch is extremely important. Difference between pitch and slope, real quick. Pitch is merely that fall or that angling of the pipe expressed in inches per foot. Slope is that exact same drop, but now we're talking about it in terms of how many feet for every 100 feet. And now when we say every 100 feet, oh, you mean in Greek percent? Yes, slope is expressed in percent. So here, this is pitch. 2.5 and smaller pipe, 1/4 inch pitch. Up to 6-inch, 1/8 pitch. I could have said 3-inch, 4-inch, 5-inch, but why would I say that when all I got to say is up to 6? We abbreviate as much as possible. Up to 6, 1/8 of an inch. Anything bigger than 6, we know we don't have 7-inch sanitary piping. There's no 7-inch no-hub. We go 8 or bigger, 1/16 of an inch pitch. How do we express this in percent slope? Well, I'll take this one for example. At 1/8 of an inch, for every foot we go down 1/8 for every foot. If we ran 100 feet, it close enough comes to you're going to drop for every 100 feet, you're going to drop a full foot. It works out to about that much, so we can say that 1/8 of an inch pitch is 1% slope. Now you're going to always hear it, and on the test it's going to happen because it's a common grammatical error, code-wise, that you interchange pitch and slope back and forth. But just so you know, technically, slope is expressed as a percentage, pitch is expressed as a fraction of an inch per foot. It's still talking about the same pipe. 1/8 of an inch pitch is 1% slope. Backflow preventers shall not be subjected to freezing. Can't put them in places where they're going to freeze. You'll destroy them. If they're in conditions like that, you have to take care of that. You have to provide for that. Somehow, some way, they have to be kept warm. Hot and cold water piping shall not be bundled in the same group. You're running your Kindorf racks. You got the cold water and hot water on the same rack. You can't put the hot and the cold together to insulate them or wrap them together for saving space or whatever. It's kind of stupid. It's like, the hot's going to keep heating up the cold's going to keep cooling off the hot. Doesn't make sense. Hot and cold got to stay separate somehow, some way. Drainage fixture unit, or DFU, is the probable discharge. Is it the exact discharge of a lavatory? No, the exact discharge of a lavatory is not necessarily one fixture unit. One fixture unit is 1 cubic foot of water drained within 1 minute. So 7.5 gallons drains from a lavatory in 1 minute. That is the cold hard rate. Is that how it always works out in real life? No. Within the drainage fixture unit is worked into, and it's adjusted such that we always understand that every single lavatory in the entire place is not draining at the same time. It's not on at the same time, or else your piping would be too big. We know that, as many fixtures as we have, there are times where they use the most or use the less, and we use the drainage fixture unit to give us an idea, and that's how we size the piping. So it's probable discharge. Drinking fountains require a separate faucet to fill a container at least 10 inches in height. That little gooseneck faucet you see, or these days now, they're making those little stations with the infrared sensor, and you just put your bottle there and the water comes out. I think LK has it. But it's got to be at least 10 inches in height to fit the bottle. Now, the stream that comes out of the bubbler must be at least 4 inches high. Why is that? Well, you're ambulatory. In other words, you can walk, right? So, if it was 2 inches high or 6 inches, you can adjust for that. There are more handicaps than just wheelchair, okay? You can have believe it or not, you can have a handicap. You actually can have handicaps where instead of being in a wheelchair, you are so ambulatory that you can't even stoop over enough. That's why there's always 2 water fountains. There's one for wheelchair. There's also one for ambulatory, because some people can't bend over to drink the water from the wheelchair. Their backs don't go that way. They need it they need it a little higher. So that's ambulatory height. That's a handicap. You can't bend over at the waist. What's another handicap? Another handicap is you can't actually drink from the stream. Yeah, for some reason, you're just unable to do that. So what these people do?